Today we take a philosophical interlude and look at problems and puzzles of induction. And it's important to note that today's problems are philosophical ones. Let's break this down. They deal with an analysis of our human epistemic capacity. So we'll turn inward and look at our capacity to make inductive inferences. They may not be important for scientific practice. So while this lecture is somewhat isolated from the rest, and this has to deal with point 3, they're isolated in their relation to other problems we go through, it is still really important. And specifically, if you want to understand your own cognitive machinery, and if you want to understand something about inductive inferences or inductive logic, these problems are really important. The outline is simple. We will discuss Hume's problem of induction, Hempel's paradox, and then Goodman's new riddle of induction. Some of this material I think is actually complementary to what we'll be doing about paradigm shifts within our next units. So let's jump right into it. Hume's problem of induction is very simple. If we want to make an argument about our experiences, the argument will probably look something like the following. In our past experience, X, some event, some regularity, has always happened, or at least regularly occurred. So in the future, X will probably continue to occur. So you can think about any sort of empirical regularity. We can think about the sun rising every single day, or the sun rising in the east. We can think about gravity acting on bodies, or acting on bodies in a very similar type of way, and human beings breathing oxygen. Pick any law-like generalization and you can apply it here. There doesn't seem to be anything tricky at all here until we look a little bit closer. The hidden premise here is the future will continue to be like the past. In other words, there is regularity over time. So we can shift the argument a little bit. In our past experience, X has always, or at least regularly, occurred. And then here's the hidden premise. The future will continue to be like the past. So in the future, X will probably continue to occur. Now let's dissect this a little bit. The hidden assumption we have here, that the future will continue to be like the past, is a necessary condition. Now it's important to pause here for a second. It's a condition without which the conclusion cannot occur. In other words, only if the future will continue to be like the past will X probably continue to occur. So if you're into propositional logic, we can put it in the following terms. If C designates future will continue to be like the past, and X designates X will probably occur, we can do the following. If X, then C, or if not C, then not X. And here, what we see is that C, that was probably a poor choice on my part, C is a necessary condition. It's a condition without which we cannot have the conclusion. I want you to think about just how much we take for granted that things are regular. Regularity is something that we understand if we amplify it or take it away. So let's go through a couple of examples that illustrate what regularity means to us or how we respond to regularity. So let's amplify regularity first. Think of the example of waking up every single morning and going about your day in the exact same way. So you eat the same breakfast, you catch the same bus to school, you finish school at the same time, you come home, you do work at the same time, you go to bed at the same time. Usually our days are slightly off in terms of regularity, and it's also very difficult for us to predict what the next move is going to be within our day. Things sometimes shift, things sometimes come out of nowhere, but for the most part our days are pretty regular. But what if every single day we woke up in the exact same position, at the exact same time, in the exact same way? Okay, campers, rise and shine, and don't forget your booties because it's cold out there today. It's cold out there every day. So Bill Murray in Groundhog Day wakes up the exact same way every single day. And while in the movie it seems as though Bill Murray wakes up like this for a series of weeks or potentially months, the original concept was supposed to be that this is over a span of perhaps hundreds of years or maybe longer. There's something very Nietzschean about this. His character goes through the cycle, this eternal recurrence, over and over again. And the only thing that he has control over is his response to the circumstances. And it's very interesting to watch his progression through the movie, his response to this amplified regularity. At first, his response is something of a sinner, and later on, his response is something of a saint. In fact, he goes through potentially the full human spectrum of emotion, and he ends with a sort of acceptance.
When Chekhov saw the long winter, he saw a winter bleak and dark and bereft of hope. Yet we know that winter is just another step in the cycle of life. But standing here among the people of Punxsutawney and basking in the warmth of their hearths and hearts, I couldn't imagine a better fate than a long and lustrous winter. From Punxsutawney, it's Phil Connors. So long. Nice speech, Phil. Very nice.
Thank you.
Thanks. How was that for you two?
Hey, man. You touch me.
Thanks.
Thank you.
I think it's interesting to think about your response to regularity, or just how much you need regularity, or perhaps how much you fear regularity. But these are existential issues. I want to approach one more existential issue, just to solidify the idea of what regularity means to us. What happens when there's non-regularity? Specifically, what if we enter a zone?
You unlock this door with the key of imagination. Beyond it is another dimension. A dimension of sound. A dimension of sight. A dimension of mind. You're moving into a land of both shadow and substance, of things and ideas. You've just crossed over into the Twilight Zone.
I don't know if you remember this episode. I think it was probably the scariest episode of the Twilight Zone. And in the Twilight Zone, the whole idea is disruption, irregularity, and non-resolution, I think. It was almost a way for us to escape from the disruptions of society by taking a look at amplified disruptions. Aside from the existential importance of regularity and non-regularity, I do think that there is actually a very interesting idea about what happens when we encounter non-regularity in science. And this is an idea that we're going to talk about a little bit later in the semester, which is the idea of shifting paradigms, or in this case, shattering paradigms. Sometimes we discover things in science that just destroy our whole web of beliefs and force us to reconstruct new ones. So here are some examples, and some of these things are things that have been confirmed, and other things are actually very interesting case studies that we're going to talk about a little bit later. So one of the examples we've already discussed, prions, which cause diseases like mad cow disease. The second one, and this is something we're going to spend a little bit of time on, is the research on neutrinos traveling faster than the speed of light. This is something that for a few months threatened a new paradigm shift in physics, until it was discovered that there was a major flaw in the scientific design. And finally, the neural space of the subconscious. I like this one very much because usually when we talk about things like Freudian psychology and the subconscious, we think of unfalsifiability. There's no scientific virtue in discussing Freudian psychology. Why? Because it's not testable. But I do think that Freudian psychology has some interesting ideas behind it. And one of those ideas is whether or not the subconscious mind is something that is accessible to the individual. According to current neuroscientific research, it seems like the answer is no. No matter how much we push, no matter how much we discover about our defense mechanisms or behavioral tendencies, we are not able to access our subconscious space. We'll also talk about this one later on in the semester. The point is simple. When we encounter non-regularity in science, it's both very disruptive as well as very exciting. We both have to tear down our web of beliefs and start a new one that might or might not be more sturdy. So let's get back to the issue and talk about degrees of confidence. The degree of confidence we have about the statement, so in the future, X will probably continue to occur, which is the conclusion, depends on the degree of confidence we have about the assumption, which is the statement, the future will continue to be like the past. The problem here is simple, but it's also subtle. Can we logically justify our inferences about the future? And the answer is no. So let's illustrate the problem. You ask yourself, why believe the future will be like the past? Well, here's an answer, because the future has been like the past. But this doesn't give us an answer. Rather, it just assumes that the future will continue to be like the past. We can break this down. In our experience, the future was like the past. The future will continue to be like the past. And for this reason, the future will probably continue to be like the past. Now you can see that there is something unsatisfying about this argument, and we have to figure out what it is. There are a couple of features of this argument that produce the problem. The first is circularity. The argument assumes what it concludes. The future will be like the past because the future will be like the past. A very specific way of putting this is the assumption cannot be justified independent of the conclusion being true. And the conclusion cannot be true without the truth of the assumption. Additionally, this argument does not give us information. So there is an aspect of uninformativeness. The information is only about the past, and think about also the future which has passed, or the future past. And there's no information about how information about the past or the future past implies information about the future. In a sense, we have a gulf between our reasoning about the past and the future past, and the new future, or the actual future, which is going to occur. The solution is unsatisfying, but interesting. Can we logically justify inferences about the future? The answer is no. We have to assume that the future will continue to be like the past, and we have no justification for this assumption, independent of assuming that the conclusion is true. So what can we do? Continue to make inferences. Will we continue to make inferences about the future? According to Hume, yes. And to ease our minds, what we should understand is we don't really care about justifying inferences while we're making those inferences. This is something that is completely natural for human beings to do. We make inferences about all sorts of things. It's a scientific fact that humans make anywhere from 3 to 400 inferences per day. I just completely made that up, but it seems like it makes a lot of sense. We make inferences about what we do, what other people do, why other people do those things, and how things work constantly. And most of the time, those inferences are pretty good. And additionally, most of the time, we experience the regularity that we predict we will experience. So humans will continue to make inferences about the future. Why? Well, because that's what humans have always done. Can we justify that humans will continue to make inferences about the future? No. This is something that we can't do. We are back to the circle of justification. The problem of induction is not something we can solve, but perhaps is not something that we need to worry about pragmatically. The ability to make good inferences does not depend on the ability to properly justify how we go about making inferences. This is perhaps the difference between scientific practice and philosophical analysis. Let's move on to Hempel's paradox. So part 1 of the paradox. The following claims are logically equivalent. All ravens are black. So if we take the statement and translate it into a conditional statement, if it's a raven, then it is black. This is equivalent to the following. Everything that is not black is not a raven. So think about the logical rule that allows us to flip this conditional statement. If it is not black, it is not a raven. What we have done is denied the consequent and denied the antecedent. Again, these two claims are logically equivalent. So there's no paradox here just yet. Part 2 is where we start to see the paradox. We can get evidence for A, that all ravens are black, by observing a lot of ravens. So think about it in terms of confirmation. If all ravens are black, then any time you observe a raven, it will be black. When we go back to our knowledge of confirmation theory, we see that the first part, if all ravens are black, is part of the theory or the hypothesis, and the second part, then anytime you observe a raven, it will be black, is part of the observational instance. So if you recall, what we have here is a conditional that has T as the antecedent and O as the consequent. If T, then O. Let's say, in fact, we observe a raven that is black. We conclude this provides evidence for the theory that all ravens are black. In other words, we confirm the theory all ravens are black. I think you're starting to see where this is going, and part 3 really fleshes this out. We can get evidence for A by observing a lot of non-ravens in the form of B. So we get confirmation, but in a very indirect way. Think about it this way. If all ravens are black, then anytime you observe a non-black thing, it will be a non-raven. You observe a non-black thing that is a non-raven. For example, a potato chip. You conclude that this provides evidence for the theory that all ravens are black. By observing non-ravens, you have made an inference about ravens. How does this provide evidence for the theory, though? It seems to not make any sense at all. If you're doing science, so in my case, if I'm studying turtles, by observing non-turtles, I go out and I observe things like aluminum cans or tires or birds in the sky, and I somehow make an inference about turtle hatching or turtle behavior. This seems to make absolutely no scientific sense. And this is the paradox. The paradox is about the nature of making inferences. We can make inferences about a phenomenon without ever observing the phenomenon in question. And this is something that is made possible by deductive equivalences. Choose a statement from any theory, put it in the form of a universal generalization, or perhaps a conditional statement, which I like a little bit more. And then if you're using a conditional statement, do transposition on that statement, and you'll get something that gives you a method of gathering observational instances that have nothing to do with your phenomenon at all. What I think is pretty cool about this is this problem derives from the intersection of deductive logic and inductive inferences. So in the scientific context, you're not usually looking for translations for claims, hypotheses, theories, models. But if you were, it would potentially make things a lot more tricky. But the other thing we have to consider is we usually want to take the most direct route possible. Sure, we can study ravens by studying non-black, non-ravens, but this will really take a lot of time and a ton of grant money. So scientifically, maybe it's really not a problem, but philosophically, it's a pretty cool one. So let's transition into the new riddle of induction, which comes from Goodman. So take a sentence like the following. All emeralds are green. This right here has a projectable predicate, according to Goodman. What this means is we can reasonably project this property of emeralds into the future from our past experiences. Emeralds have been green. We've counted a lot of different emeralds. They're always green. And for this reason, we make the inference that all emeralds will continue to be green. Sure, we still have Hume's problem, but we might have an even larger one. Take a new term, GRU. Something is GRU if it is green and first observed before New Year's Day 2020, or blue and first observed after that. This seems really unusual for us to say, but consider it for a second. On this characterization, all emeralds are GRU because they have not failed to be GRU. Moreover, and this is where we see the problem, the inductive support that emeralds will continue to be green is exactly the same as the support for emeralds being GRU. You might think, well, GRU is not a projectable predicate because we haven't experienced something that is GRU. And the counter might be, we haven't experienced it yet. So perhaps we just haven't really been on the earth long enough, or haven't really paid much attention to things that have a temporally shifting nature. Maybe things are shifting all the time, and we just haven't really paid much attention to it because our human mind is much more comfortable with stable things, stable properties. Or maybe it really takes a long time, and humans have only existed, like 190,000 years? We really haven't experienced things that change over time. And in the year 2020 will be our first observational instance of something that does. There might not be a clear reason to reject GRU as a predicate and to accept green as a predicate. But if you think there is such a reason, you got to tell us why. So in our inferential activities, what's the difference between projectable and non-projectable predicates? If you think that GRU is non-projectable, the question is why? Is it because of past use in predicting things successfully? Using the predicate green has been very successful for us practically. But again, the answer is maybe it won't continue to be in the future. Perhaps at a certain time there will be a shift, and GRU will be much better at predicting things successfully. And in fact, it might be even better at predicting things successfully over gigantic periods of time. Or you might say, what about the fact that it's currently unfalsifiable? So we don't like things that are unfalsifiable. Green is something that you can falsify. You take a look at an emerald, it is or is not green. We have an observational instance that allows us to make the theory false. And this is something that is accessible to us right now. But GRU will be falsifiable. It's just in the year 2020. So that's not a great objection either. What about the idea of using natural kinds as predicates? It seems like green is just something that has boundaries in the world, whereas GRU is something that is constructed or spliced. We don't usually have properties that are part temporal and part physical. But I want you to think about using temporally relative predicates in general versus stable ones. There really is no reason to view certain properties as natural kinds and other ones, which are temporally relative, as unnatural kinds or constructed properties. To figure out the difference between projectable and non-projectable predicates and to solve the new riddle of induction, we really need an independent criteria to decide between predicates. This is something that I think is a worthy philosophical project, and I do think that it is possible to justify the difference between predicates based on pragmatic and scientific considerations. But if we're looking at this purely philosophically or linguistically, it would be very difficult to draw a sharp line between projectable and non-projectable predicates. For those of you interested in such careful work, I encourage you to move forward with it and potentially find a new solution. So let's summarize what we've done. We've taken a look at Hume's problem of induction, Hempel's paradox, and Goodman's new riddle of induction. And I want you to notice that all of these point to the difficulty of making inferences. These inferences can be about the future, about classes of things, and about our choice of predicates. And the thing about these problems is we don't really have solutions. And I think this is important to note. What are these problems for? And usually we think problems are for the purpose of finding a solution. So we might be able to generate solutions. We should strive to generate solutions. But in these cases, it doesn't seem that these problems are for solutions. Rather, these problems are for the purpose of pointing out interesting puzzles that help us to further understand our inductive reasoning practices. These problems give us a mirror in order to understand how we reason about the world. I think this is a good way to pause on the material a little bit and reflect on things philosophically. If you're interested in these kinds of issues, please take Philosophy 61, Inductive Logic. But like I said before, this is kind of an isolated topic that, while philosophically important, is scientifically perhaps inapplicable. At least not until we get to the concept of paradigms and world shifting with paradigm shifts. Thank you very much, and I will see you all next time.